Hello everyone, in this video I'll talk about how to recrystallize something and what's really the need behind doing a recrystallization. So let's suppose you did an organic reaction where you made it in the compound or the product and you trying to purify it. Now, you may very well run other techniques as well to purify compounds such as extractions and chromatography and whatnot. But even sometimes after running an extractions and chromatography, you may not actually have a compound that is very pure and or the purity that you're kind of looking for. So in those cases, recrystallizing that particular compound is going to be the way to actually get that compound purified. So suppose I have a reaction where I mixed two chemicals, let's say A and B, just generically, and I used some sort of solvent, and that eventually made a compound AB, and some impurities along with it. And the impurities are not only made on the product side, but you may have some of the reactants kind of left behind, and then you got to worry about how you're going to be getting rid of them. So one ways to do it is obviously crystallizing something. And let's suppose I got this AB compound, the organic compound that we made here. It might actually precipitate out. And once it's precipitated out, you want to go ahead and recrystallize it in a choice of solvent. Now, the solvent selection is very critical. You want to make sure that you pick a solvent where your compound is actually soluble only at high temperatures. So suppose I have the compound of the interest rate, like right there, AB. So I want to pick a solvent where it has low or almost not soluble at low temperature. And ideally, you want to have the impurities soluble at all temperatures in that particular solvent. Now, finding that solvent does take a little bit of time, and you have to figure out what's that particular solvent going to be, and you can run a little bit of a test to kind of figure that out. Like for example, I can get a bunch of these let's say test tubes, and suppose I got this one test tube here, and then I want to go ahead and add a little bit of your compound here. Let's say I add a little bit of an AB here, and then you want to go ahead and pour the solvent, and let's say I pick acetone as one of my options, and then I can run other options as well. Like I can have, suppose I'm gonna go and copy this down here. I got multiple of those, and I'm gonna be testing the solubility at the low temperature for these guys. So I want to be using acetones. Maybe I use ether. Probably not ether. Ether is really not a good one to kind of heat. Let's say ethanol is another one that can be used. Water is another one, and maybe I can use ethyl acetate or something. And sometimes you may have to use a combination of solvent, and that's become important as well. Like sometimes it doesn't really dissolve in one solvent, then you want to use a combination of solvent as well. If you see that particular compound actually is dissolving at lower temperature in any one of those solvents, so you want to cross that solvent out. Like suppose this particular compound, the AB, dissolves or it's soluble in acetone at room temperature at 25 degrees Celsius, then that's not really a good solvent. I don't want to be using that. So, and then I want to say, let's say it's insoluble in methanol at 25. So that's a good sign. I want to kind of pick that in my selections. Let's say it's also insoluble in water at 25 degrees Celsius. Then I want to pick that one also as my option. And I can also say it's insoluble at 25 in ethyl acetate. So I want to pick that as an option as well. Now, I know now I just kind of ruled out the acetone here. The other three, which one I really wanna pick out of those three, you're gonna have to test those one by one. And suppose the next thing you want to do, you want to go ahead and heat those up. And when I'm heating those up, if it dissolves at a higher temperature, so like let's say I'm going to go ahead and take all these three test tubes, I'm going to warm those up, and I'm going to be heat those or heat them to boiling point of those respective solvents. Like they will have different boiling points, so you got to be careful with. So when I'm heating it up, if they dissolve at a higher temperature, then that's a good thing. That's really what you want. You want to make sure it dissolves at a higher temperature and it doesn't really dissolve at a lower temperature. So if you see in a situation where it doesn't really dissolve at a higher temperature, so like let's suppose this guy right there, it's not soluble at, I don't know, at a higher temperature, let's say around, I don't know what the boiling point of ethyl acetate is, but let's just say not soluble at higher temperature at all, then in that case, I want to rule that out. I don't want to be using that solvent. So then I'm down to like, let's say an ethanol and water, and you may very well be, getting in a luck in any one of them. So let's suppose it does dissolve at higher temperatures. So maybe I want to go ahead and pick that. I can test the ethanol as well. If it does dissolve at a higher temperature, you can pick that one as well. Now, just my preference between the ethanol and water, if I have to pick one or the other where both of them seems to be working, I'll probably just go with water just because it's cost effective as well and you don't have to worry a lot about the waste as well. But still, you got to worry a little bit about the waste because you may have the water contaminator. You still want to put them in the particular waste container, but it's just the cost. Like you have to actually buy the ethanol, but water you can just use the one out of faucet. So let's say it does dissolve at a higher temperature. So the whole point is I want to go ahead now, use a beaker, and in the beaker I want to add all my salt that I just, not salt, the compound that I just created. So this is my compound AB, and then I want to add a little bit of water at a time. So I want to add some water, a very small amount of water at a time, and then I want to heat them up. So using a hot plate or something to kind of heat it. And while I'm heating this up, I want to see if any of those compounds is dissolving, and sometimes it does requires a lot of patience because it's something once it starts dissolving, it would dissolve quickly, but it does take its precious time. You want to add a little bit of water, see if it dissolves, and if the water starts kind of boiling at some point and it's still not dissolving, you want to add a little bit of more water, and that's how it should be done. You want to add a little bit of water at a time until everything is dissolved. So suppose you get to a point where you have added enough water and everything dissolves now. So I'm going to go ahead and get another point here where everything is dissolved. So when everything is dissolved, you should see a clear solution. So the clear solution means you do have an AB, but it just dissolved in there, so now it's in a clear solution. Now, if it's in a clear solution, all right, that's one possibility. If it's a clear solution, what I want to do is I want to go ahead and settle this down on the side. So remove it from the hot plate and set it aside and let it cool down very, very slowly. So once it's cooling down slowly, and we know that the AB, or the compound of interest, doesn't really dissolve at a lower temperature, it would eventually start crashing out. Now, the thing about the solubility and recrystallization is once it starts crashing out, it would only get the molecule of interest in the crystallizing form. So they, like, the molecule of AB, they would like one another, and they are going to be the only one that kind of get together to kind of make the crystals. And once you start seeing the crystals being forming, and once it kind of gotten down to the room temperature, you can go ahead and put them in the ice bath where you can get all the crystals you can possibly get. And sometimes you may run into a scenario where the solution becomes super saturated. What that means is, like, like even though it has cooled down, but you don't really see any precipitates. And in those cases, you gotta do a technique called seeding, where either you can add a crystal from your own of this compound, just a little bit of tiny speck in there, and then it should start crystallizing the whole thing. Or you can also use a spatula, and you can kind of scratch the inside of the glass and see if it helps you to get the crystals. Now, once you get this, I want to go ahead and let it cool down, put them in an ice bath. And once you have put them in an ice bath, you got all the crystals, you want to go ahead and do the vacuum filtration. And once you do the vacuum filtration, you want to make sure you run it for about like 10-15 minutes, let it dry and whatnot. And you want to go ahead and get the melting point and the weight and everything. So dry the crystals and weigh them and then get the melting point. Now, once it's purified, the melting point of pure compound should be very sharp. When we say it's going to be anywhere between like 1 to 2 degrees Celsius range. So if the compound's supposed to melt at, let's say, 78 degrees Celsius, you may see the range as 78 to 79 degrees Celsius once it starts melting, and by the time it reaches 79, all the compound has been melted. But if this was like something crude or impure compound, the impure compound melting point is going to have a larger range. It's not going to be 1 to 2 degrees Celsius. And on the top of that, it's going to be starting at a lower, it's going to start melting at lower temperature with that particular range. So suppose, like I said, it was supposed to melt at, let's say, 78, 79. That would have been the narrow range. If this was an impure, it may start melting at, let's say, 70 degrees Celsius, and it goes all the way to like 79 or 80 degrees Celsius. So that's another larger range, and that's how you know the compound is itself going to be an impure. Now, this is in a ideal conditions where you don't really see anything in terms of there's no uh, um, it's in a clear solution, you let it cool down, and you make the crystals, and then you filter it. But now, let's say if you run into a situation where you don't really get a clear solution, like you do get most of the compound dissolved when you go ahead and heat it up. So let me just gonna copy this and put it down here. So I have this dissolved here, but then I do see a little bit of specks here and there, and those specks would be, it's mostly clear, but then you have some impurities in there that are not dissolving even at higher temperature. So this is at higher temperature. The impurities are not dissolving. And in that case, what you want to do is you want to go ahead and run so-called the gravity filtration, or to be more exact, it's a hot gravity filtration. So when you're running in a hot gravity filtration, the compound of interest is actually already in the solution. What you're really trying to do is you're trying to get these impurities stuck in the filter paper so they're not really the part of the solution anymore. And why you're running hot is just to make sure that if the solution actually cools down, you may start seeing this AB, or the compound of interest, getting crystallized in there, and you don't want to be doing that. So you run the hot gravity filtration. When you're running the hot gravity filtration, you want to make sure you use the hot solvent to warm up your funnel, and you also warm up the filter paper. So you want to add a little bit of hot solvent onto the filter paper and let it run through um, the funnel, and you want to put the beaker or the receiving beaker on the hot plate so that as soon as this liquid goes onto the gravity filtration and it passes through the funnel and eventually make it to a new beaker, it's not crystallizing in there. Even if it does crystallize, not really the end of the story. You can still warm it up and you can have that a compound of interest dissolved. But the whole point is you would have these impurities kind of gotten rid of. Now, at some point, like sometimes what you do is you would also have this solution to be like a little yellow or pale in color. And if you want to kill those impurities or kill that color, you can also add charcoal or carbon. So it's going to get added in there and it's not going to dissolve in there, and that's completely okay. You're running in a gravity filtration where you will have all that stuck in the filter paper. So, this is really the funnel I got, and then I would have a new filter paper, a new beaker here that would be put it on a hot plate because I want to make sure it kind of warms, stays the solution warm, and I have this filter paper in there. Pardon my drawing there. And then I want to go ahead and add all of that solution into here. So solution goes in there. You would have your some of those impurities stuck in there, and you would also have some charcoal kind of left in there. So this would have impurities and the carbon or the charcoal left in there. So charcoal sometimes is used to kind of eat up that yellow color of the solution. And then what you're really going to get at the end down here, that is going to be your pure solution containing AB. So it does not have any impurities in there. It's just going to be clear solution. And if it does crystallizes while, like if it does crystallizes in the funnel's neck or anything, you can use the hot solvent to kind of run it through the filter paper and have those AB compound or the compound of interest dissolved in there, and that go into the solution of this beaker. And if you start seeing this being crystallized here, then you are on a hot plate, so you can go ahead and warm it up. And in that case, you can once all that dissolved, you just follow the process that we done on the right side, where you take it out from the hot plate, let it sit down and until it crystallizes. And once it starts crystallizing, reach the room temperature, you can put them in an ice bath. And once all said and done, you can run in a vacuum filtration after that. So that's really what you're really going to be doing for the recrystallization. And that's really the bottom line and how the process is being done.